So this is notes 7, page 4. We're going to see that order makes a difference with radicals and powers. We know it makes a difference with order of operations. So we looked at some previous examples. We were doing the inverse operations, powers and radicals. But in the previous examples, we first took the root and then took the power that undid the root. Now we're going to do this in reverse order. And when we do it in reverse order, things get a little trickier. So here's our starting number, -4. Okay, the first thing I'm going to do is square that number. Okay, and then I'll take the square root. So I'm undoing the square with the square root, but I'm taking the square first. Now when I square -4, that is a negative times a negative, so it's positive 16. So I have the square root of 16, which is 4. So did we get back to exactly where we started? No, we started at -4, we ended up at +4. We lost that negative sign. So we didn't get back to exactly where we started, but 4 is definitely related to the -4. We just lost a negative sign. We can say that we wound up with the absolute value of -4. So in words, the absolute, didn't leave enough space here, value of our starting number. Because the absolute value removes the sign, and basically when we squared, we lost that negative, so we can never get it back. Now, this is only a problem for even powers. Let's consider an odd power. Suppose we take -4 to the third power and then take the cube root. Well, -4 cubed is -4 times -4 times -4. That's a triple negative. That will be -64. And then we take the cube root of -64. Well, that answer is -4. I started with -4. When I applied the cube, oops, I forgot my little index here, and the cube root, I got back to exactly where I started. I always think about the card game Go Fish. I got what I wanted. So this weird thing of losing the negative sign of the original base only happens first when you apply the power first, and it has to be an even power, and then you take the square root. So this is something that's extremely important. If x is any real number, you don't know if it's positive or negative. When you take the square root of x squared, you might get x back if x is positive, but you might only get the absolute value of x back. Since we don't know what x is, the best we can really say is the square root of x squared is the absolute value of x. And this will actually become important when we solve some equations. And in general, if you have x to an even power, then take the even root, you will not always get back to exactly what you started with the x, but you will at least wind up with the absolute value of x. Now, if you have an odd power, you always get back to exactly where you started. You will never need an absolute value if it's an odd power, odd root. So there are a lot of little details to keep straight here. And I'm actually going to mess with your brains and make it harder, because most of the problems are going to say, assume x is positive. Well, if x is already positive, then the square root of x squared will just be x, because the absolute value of x is just x, right? The absolute value of a positive number is just itself if x is positive, greater than 0. So a lot of the problems are going to say assume x is positive, you're not going to have to worry about the absolute value. But there'll be a few problems where I'll say, x could be any real number. It might be positive or negative. Then you have to worry about the absolute value. So here, I did not tell you to assume x was positive, but notice it's an odd power to an odd root, and so the fifth power, and then you undo the fifth power by the fifth root, you will get back exactly what you started with, which is the negative 4x. But here, again, I didn't tell you x or y was positive. They could be negative. I've got an even root, and I'm taking the square root. At best, I'm going to get back the absolute value of x times y. And then here, m to the fourth. You see how the fourth power would actually hide the fact that m was negative? So then when you took the fourth root, you would never get that negative back, but you will at least get the absolute value of m. And then finally here, see, now I've reversed the order. I take the fourth root first. Well, if I'm taking a fourth root, m had already better be positive. So the fourth root of m raised to the fourth power will just be m, because this is not going to work if m isn't positive, and so we're not going to lose a negative. It is just m. So, and the little comment here, as long as the fourth root of m is a real number. And the fourth root of m will be a real number when m is positive, greater than 0. Okay, so some details there. All right, I think I will actually stop here and do this page with the next one, because that's all connected. Some really, really important patterns that's going to help simplifying with radicals easy.